Greetings, Pre-Calc students. Last lesson from Chapter 8 coming up here on trig inverses. You may recall that when we did some inverse trig functions in Chapter 5, pretty much whenever we use the inverse key in a trig function, we're looking for an angle. And so that's going to be pretty much the same case here, although a few different twists involved here. So please copy this chart down. This will become pretty handy for you for this particular lesson anyway. Anyway, notice we have three different functions, and we would call it inverse sine, inverse cosine, inverse tangent. And we have fancy names for them with the word arc in front of them. They really mean the same thing. Arc sine is the same as inverse sine, and so on and so forth. Now, when we talk about that inverse with functions, we remember that we flip or switch the domain and the range, or the x and y. And it's kind of the same thing here. If you remember what the normal domain and range are for sine, cosine, and tangent, these are kind of switched around. The only thing we do here is we've kind of limited the range. The range has been restricted, and the reason for that is so we can meaningfully talk about these inverse trig relations so that we can officially talk about them as functions. And we'll see this when we look at and examine the graph of these. So here's the domain. As you can see, sine and cosine are quite identical here as far as the domain. The range is your y values. Here they're different. If you remember, sine and cosine were exactly the same when we talk about the regular sine and cosine function. Their domain and range were exactly the same. Here they're a little bit different. And probably a good way to think about this, and I'd even add this in your notes, is think about what quadrant you can find your answers in. And so, for instance, if I look at inverse sine, when I look at this range here between negative pi over 2, so that's going down this way, and positive pi over 2, that's going this way, in a sense, that means quadrants 1 and 4. So I think it'd be wise for you to write this in somewhere here. Just put a 1 and a 4. That means if I'm looking at my circle chart, those are the two quadrants I can look for to get my answers. Here's inverse cosine. Again, I'm going to think about quadrant signs that I can put in there. And when I look at between 0 and pi, those are actually quadrants 1 and 2. That's where I can look for my answers for inverse cosine. And inverse tangent, you can see, is very similar to inverse sine. So those two quadrants would be 1 and 4. That'll make more sense here in a second when we go over some examples. But take a look at these graphs, what they look like. I've just obtained those by essentially putting this in my y equals, the inverse sine, inverse cosine, inverse tangent, setting my window appropriately so it kind of fits the domain and range here, and that's the kind of graphs that I get. Again, keep in mind that all of these inverses that you see here are functions, and that's one reason why these ranges are more condensed than usual, is so we can meaningfully and legally talk about these as functions. Alright, so we're going to move on to the next slide and actually do some problems here, but certainly pause it if you need to so you can. Alright, evaluate each expression, arc sine of negative 1/2. So basically, remember, we're looking for an angle here, the angle whose sine is negative 1/2. So if we think about this on the circle chart here, I'm just going to kind of draw this out a little bit. Where sine is negative 1/2, that's going to be down here someplace, because that's my y values being negative 1/2. And seemingly I can have two angles here, one negative one that drops down here, one positive one that swings way around over here. And so if you actually do this in your calculator perhaps, you would get a certain degree or radian answer, but you might recognize that negative 1/2 is something that's on your circle chart. And sure enough, if you do this, you get, or take a look on your circle chart, you see that the two places where we could have potential answers, as we marked out, are here and here. and down here this would be at 330 degrees. We like to write this as perhaps negative pi over 3, simply because if you remember the chart you just wrote down, the way that the domain was written there. So negative pi over 3, it's the same as 5 pi over 3 or 330 degrees. And it looks like this spot over here would also be legal, and that appears to be, I think, let's see, would it be 7 pi over 6? I don't have my circle chart handy here. And it would be, yeah, 7 pi over 6 right over here. Now the catch is, though, here, we have to go back or think about that last chart that we made. Whenever we see these arc things, we are limited in our answers. And actually, what quadrants can I look at? Well, for inverse sine, the only quadrants I can look at for my answer that we wrote down are 1 and 4. So this guy right here, we have to eliminate. That's in quadrant 3. That cannot be a part of my answer here. So my final answer, the arc sine of negative 1/2, is this guy right here, negative pi over 3. All right, moving on to the next example over here. This one, the inverse tangent of the sine of pi over 2. Well, here we can work from the inside out. I know that the sine of pi over 2, that's like the sine of 90 degrees. That's equal to 1. So I can put my 1 in there. And then I ask myself, well, what's the inverse tangent of 1? In other words, the tangent of what angle gives me 1? And if you look on your circle chart or you have some knowledge about this, that's going to be a 45-degree angle, pi over 4. Now there's another tangent that also gives us 1 down in the third quadrant. That would be 5 pi over 4. But remember, with these inverse things, we are restricted. Basically, the two quadrants that were given, one will give you positive values of your answer, one would give you negative. So that's something to keep in mind there as well. So keep in mind we're not quite done yet here. Yeah, we are with this one. Sorry about that. All right, because the inverse tangent of 1 is pi over 4. But what I was going to say is we can only look at one quadrant. For tangent it was 1 and 4, and the one that's positive here is actually quadrant 1. Another good example here. This one looks even a little bit more daunting, but again, we'll take our time with it and just kind of work from the inside out. So the cosine of the arc tangent of the square root of 3 minus the arc sine square root of 3 over 2. So I won't do anything with this cosine right here at the moment. What about the arc tangent of the square root of 3? So I'm looking for an angle that has a square whose tangent is the square root of 3. So hopefully you had written down all those tangent values on your circle chart. You can take a look at what this is. I'm going to write this in degrees since we're going to have to do some subtracting here. And I'm pretty sure this is going to be 60 degrees for the arc tangent of the square root of 3. Now the arc sine of the square root of 3 over 2, again, sine of the square root of 3 over 2 could be a couple different values. But where is my sine value going to be? The square root of 3 over 2? Well, that's also going to be at 60 degrees, I believe. So if you look at 60 degrees and you look at, well, what's that sine of 60 going to be? Sure enough, it's going to be that square root of 3 over 2. So there I have 60 minus 60, and so that's going to give me the cosine of 0 degrees. And just through some common sense or looking at your circle chart, you should remember that the cosine of 0, cosine is your x value, remember. So at 0, we're at the furthest right we can go. So my answer here ends up to be 1. All right. Now, could you do all that stuff in your calculator? Perhaps, but want you to have a good understanding of how we got from the initial problem here to the very end. Sometimes the calculator kind of hinders that a bit. So I like to draw things out and think about them and make sure we're obeying all of the fancy trig rules when we do these. All right, so that's a good one. Here, true or false, give you a statement here, and if it's false, give a counter example. All right, so let's see here. What we could do with this one, the inverse sine of the sine of x equals x. So that's kind of interesting. Let's just pick something familiar and see if we can get it to kind of work out here a bit. Let's just say that x is 2 pi over 3. That's about 120 degrees, I think. So then if I plop that in here, again, I'm just getting a feel for whether this might work or not. So the sine of 2 pi over 3, does that actually equal 2 pi over 3? Well, the sine of 2 pi over 3, 2 pi over 3 is 150 degrees, no, 120 degrees, excuse me. 120 degrees, so the sine of that up there is going to be the square root of 3 over 2, I believe. And so then we have the inverse sine of the square root of 3 over 2. Will that always get me back to the 2 pi over 3? Well, perhaps, but if we remember my restrictions for the inverse sine, it must be in what? A certain number of quadrant numbers. So for sine, it was quadrant 1 or quadrant 4. So none of these problems are terribly difficult, but it's just kind of tricky to remember what quadrant they have to be in. And again, we are restricting or limiting the quadrants just in order to meaningfully talk about these things as functions and enjoy all the benefits that they have. All right, thanks for hanging in there, everybody, and we'll see you guys in class. Bye now.